Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. Now, this second video lecture is the continuation of my previous first video lecture of week 13 for the course Biostatistics 1. In the first video lecture, we have learned about sampling and sampling distribution. But in that video lecture, we have discussed uh, about the probability sampling and non-probability sampling, which is related to sampling and sampling distribution. Now, in the main topic, sampling and sampling distribution, today we are going to learn about this subtopic, which is called sampling error and non-sampling error, which is related to sampling and sampling distribution. So first of all, I would like to tell you about the sampling error. Sampling error denotes a statistical error arising out of a certain sample selected being unrepresentative of the population of interest. In simple terms, it is an error which occurs when the sample selected does not contain the true characteristics, qualities, or figures of the whole population. The main reason behind sampling error is that the sampler draws various sampling units from the same population, but the units may have individual variances. Moreover, they can also arise out of a defective sample design. Faculty demarcation of units, wrong choice of statistics, substitution of sampling units done by the uh, enumerator for their convenience. So, moreover, they can also arise out of defective sample design, faculty demarcation of units, wrong choice of statistics, substitution of sampling unit done by the enumerator for their convenience. Therefore, it is considered as the deviation between true mean value for the original sample and for the original sample and the population. Now, non-sampling error. Non-sampling error is an umbrella term which comprises of all the error other than the sampling error. They arise due to a number of reasons, that is, error in population definition, questionnaire design, approach, coverage, information provided by the respondents, data presentation, collection, tabulation, and analysis. There are two types of non-sampling error. One is response error. The error arising due to inaccurate answers were given by the uh, researcher, were given by the respondents, or their answer is misinterpreted or recorded wrongly. It consists of researcher error, respondent error, and interviewer error. So, this is the type of non-sampling error. Non-sampling error has two types. So one is the response error. A response error is the error arises due to inaccurate answer were given by the respondent, or their answer is misinterpreted or recorded wrongly. It can consists of researcher error, respondent error, and interviewer error. Now, non-response error. Error arising due to some respondent who are a part of the sample do not respond. So this is the non-response error, in which the res- the response the response the errors arising due to some respondent who are a part of the sample of who are a part of the sample do not respond. Now, difference between sampling and non-sampling error. You see over here, number one, sampling error is a statistical error, happens due to the sample selected does not perfectly uh, represent the population of interest. And similarly, non-sampling error occurs due to sources other than sampling while conducting survey activities is known as a non-sampling error. Number two, sampling error arises because of the variation between the true mean value for the sample and the population. And similarly, the non-sampling error arises because of deficiency and inappropriate analysis of data. Number three, sampling error is mainly associated with the sample size. That is, as the sample size increases, the possibility of error decreases. Similarly, number three difference for the non-sampling error. The non-sampling error is not related to the sample size. So, with the increase in sample size, it would not be reduced. So, these are the three differences between the sampling error and non-sampling error. Now, sampling distribution. A sampling distribution is a probability distribution of a statistic obtained through a large number of samples drawn from a specific population. The sampling distribution of a given population is the distribution of frequencies of a range of different outcomes that could possibly occur for a statistics of a population. Now, there are some characteristics for the sample distribution, and these characteristics are called the parameter and the statistic. When we have collect the data, we have a whole set of number of description written down on a paper or stored on a computer file. We try to summarize important information in the sample into one or two numbers called a statistics. For each statistic, there is a corresponding summary number in the population called a parameter. So, dear student, note that a parameter is the characteristics of population, and statistic is actually the characteristics of the sample. Now, measure of quantitative variables. There are two basic statistics when we have quantitative variables, the mean and the variance. The mean measures the center of data, while the variance measures the spread out of data from its mean position. Now, the population mean is denoted by mu. The population variance is denoted by rho square. The standard deviation of the population is denoted by rho, and the sample mean is denoted by x bar. The sample variance is denoted by s square. The standard deviation of the sample is denoted by s. We have already learned about these terms. Now, measure of qualitative variables. The measure of the qualitative variables, that is, the characteristic which we want to study in the population. The characteristics which we want to study in the population are called measure of the qualitative variables. Is called the proportion. Thus, we have the population proportion P is equal to the number of characteristic in the population divided by this capital N, and the sample proportion R is equal to the number of characteristic in the sample divided by small n. Note that the proportion must be numbers between 0 and 1. A percentage may be obtained by multiplying the proportion by 100. Now, probability sampling. Every population element has a chance of being chosen for the sample with known probability. Number 2, non-probability sampling. Not every population element has a chance of being chosen for the sample, or the probability of choosing an element is unknown. For the statistical methods, it is useful to use the first type, thus we do not consider the second type. The simple random sampling is the basic kind of probability sampling. We have two cases for sampling. Number 1, sampling with replacement. The number of all possible samples of size n, this is small n, from a population of size a capital N with replacement is k is equal to n power n, capital N power small n. This is sampling with replacement. Now, sampling without replacement. The number of all possible samples of size small n from a population of size small capital N without replacement is given by this formula. K is equal to nn, and this is actually the notation of the sampling without replacement. And the sampling without replacement is given by n factorial, capital N factorial divided by n small n factorial into capital N minus small n factorial. N above n, small n above capital N. This is the combination formula. So this formula is used will be used for the sampling without replacement. Now we can use the following steps to obtain the sampling distribution of the sample mean x bar to find all the possible samples of size n from the population of size capital N, and to calculate x bar for each sample, where x bar is equal to sigma x divided by small n. So we can use the following steps to obtain the sampling distribution of the sample mean x bar. Number 1 step, to find all possible samples of size n from a population of size capital N. To find all possible samples of size small n from a population of size capital N. Number 2, to calculate x bar for each sample, where x bar is equal to sigma x divided by n. Dear students, note that this is actually the mean of a sample for a population. And to construct the frequency table for all different values of x bar, and also the frequency of each value, that is the total of frequencies, which is equal to k. To study the sampling distribution of the sample mean and its relationship with the population parameter mu and rho square, we need to find its mean, which is denoted by E of x bar. This is called expected mean, and this is equal to mu x bar, and its variance is equal to V of x bar is equal to rho x bar square. This is actually the population parameters mu and rho square. Mu and rho square are the population parameters, and we need to find its mean, denoted by E of x bar is equal to mu x bar, and its variance is where V of x bar is equal to rho x bar square. And as follows, we can find these by this formula. Mu x bar is actually equal to sigma f of x bar divided by k and rho x bar square is equal to sigma f of x bar sigma of f into x bar square minus k mu x bar square divided by k. So these are the formula for the population parameter, and this is actually the sampling distribution of sample mean x bar. Now, dear students, in the coming video lecture, we will discuss some numerical problems for the sampling distribution. Now, the conclusion of video lecture of this week, dear students, note that actually we have learned about some definitions for the sampling and sampling distribution. First of all, I have already told you about the definition of sample and a population. A sample is actually a sub part of the population, and then we have discussed the sampling. Sampling is actually a process by which we select the sample from a population. And then we have learned about the types of sampling, which is called probability sampling and non-probability sampling. And in this video lecture, we have discussed some other definition of sampling error and non-sampling error, like you see over here in the first slide, that what is a sampling error. This is actually the sampling error definition. Sampling error denotes a statistical error arising out of a certain sample selected being unrepresentative of the population of interest. And there are types of sampling error. One is non-sampling error and other is sampling error. So sampling, this is the definition of the sampling error. Now, non-sampling error. Non-sampling error is an umbrella term which comprises of all the errors other than the sampling error. The error rises due to a number of reasons. Non-sampling errors arises due to a number of reasons. The reason is number one, error in problem definition, error in questionnaire design, error in approach, error in coverage, error in information provided by respondents, or data preparation, collection, tabulation, and analysis. So, due to all these errors, when the error arises, then the error called non-sampling errors. Now, non-sampling error have some two types. Response error. From the name, it is clear that this error arises due to the response. Error arises due to inaccurate answer were given by the respondents. When the respondent gave the wrong answer, the error will be arises, and so the error called the response error. Or the or their answer is misinterpreted or recorded wrongly. Sometimes the answer of the respond will be clear, but maybe the answer is misinterpreted or the answer will be recorded wrongly. Then this error also called the response error. It consists it consists of researcher error, respondent error, and interviewer error. Maybe due to the researcher error, maybe due to the respondent error, maybe due to the interviewer error, the error arises, then the error called response error. And non-response error, error arising due to some respondents who are a part of the sample do not respond. So error arising due to some respondents who are a part of this sample do not respond. Then the error called a non-response error. Now, dear students, you see over here, these are the main difference between the sampling error and non-sampling error. Sampling errors is a statistical error, and non-sampling error occur due to sources other than sampling while conducting survey activities is known as non-sampling error. And similarly, sampling error is statistical error happens due to the sample selected do not perfectly represents the population of interest. Similarly, sampling error arises because of variation, and the non-sampling error arises because of deficiencies. Number 3, sampling error is mainly associated with the sample size, but the non-sampling error is not related to the sample size. So these are the difference between the sampling and non-sampling error. Now this is the main topic, sampling distribution. A sampling distribution is a probability distribution of a statistic obtained through a large number of samples drawn from a specific population. The sampling distribution of a given population is the distribution of frequencies of a range of different outcomes that could possibly occur for a statistic of a population. Now, dear students, in the sampling distribution, we will measure the quantitative variables. There are two basic statistics which we have quantitative variables, the mean and the variance. The mean measures the center of the data, while the variance measures the spread out of the data from its mean position. So, how we can calculate measure of quantitative variables? The measure for the quantitative variables is called the proportion, and we have these proportion is proportion, population proportion P, and sample proportion R. Population proportion P is given by the number of characteristics in the population divided by capital N, and R is equal to the number of characteristics in the sample divided by sample N. Capital N is actually denote the number of individuals in the population, and small n denote the number of individuals in the sample from the population. We select the sample from the population. And dear students, note that sampling without replacement and sampling with replacement and sampling without replacement. The number of all possible samples of size n for a population of size n with replacement is given by k is equal to n above n power n. And sampling without replacement, the number of all possible samples of size small n from a population of size capital N without replacement is given by n above n. This is actually the combination is equal to n factorial divided by n small n factorial n to capital N minus small n factorial. So dear students, note that now we can calculate the population parameter. These are the population parameter mu and rho square. Mu is the mean of population, and rho is the standard deviation. Rho is the variance of the population, and parameter actually called characteristic. So we need to find the mean, which is denoted by E of x bar. This is expected mean is equal to mu x bar, and its variance is equal to V of x bar is equal to rho x bar square, which is given by this formula. Mu x bar is equal to sigma f of x bar divided by k, and rho x bar square is equal to sigma of f into x bar minus k into mu x bar square divided by k. Inshallah, in the coming video lecture, we will discuss some numerical problems about the sampling distribution. Now, this is the end of this segment. Thank you. Allah Hafiz.